We've already seen how to utilize induction to be able to prove summations and then also to prove formulas with respect to divisibility. In these last couple of videos, we're going to take a look and see how to utilize induction to be able to prove statements that contain inequalities within them. So we'll start out with one of the easier types. So we have that for all n in the integers, if n is going to be greater than 3, then 2n plus 1 is less than 2 to the n. All right, so we're not really going to deviate from the pattern too much, at least for the first two steps. But then when we get to step 3, that's really where this is going to be different than the other two types of induction we've seen. So step 1, when we go through induction, is always the basis step. And right here, what we're going to say is, let's let n be equal to 3. All right, and remember, it's for any value such that n is greater than or equal to 3. Let's just let n equal 3, the smallest value. Okay, by substitution, we can see that we get 2 times 3 plus 1 is going to be less than 2 cubed, which is the same as saying 7 is less than 8. And that's certainly a valid statement. All right, so it seems that the basis step is going to hold for small values of n. So thus, the basis step seems to hold for small values of n. Okay, now this is where we're going to use the inductive step, and we're going to assume that it holds for all n equal k. Okay, so assume the inequality is valid for all n equals k, where k is an integer. Okay, thus we can say that 2k plus 1 is going to be less than 2 to the k, okay, for where k is going to be greater than or equal to 3. All right, and we're going to use this actually in step 3 right here. All right, when we start that. Okay, so our first two steps, same thing as we've always done. We've had the basis step, and then we've had the inductive hypothesis. Okay, so remember that this is going to be, I'm going to put this in brackets. This is our inductive hypothesis. Okay, now what we're looking for in step 3 is we have to somehow verify that the formula is true for when n equals k plus 1. Okay, so we're going to prove when n equals k plus 1, or in other words, we have to somehow get to 2 times k plus 1 is less than 2 to the k plus 1. All right. And so we're not going to do this where we do substitution. Okay, usually that's how we try to approach these. But for this one, what we're going to do is we're just going to use the inductive hypothesis to start with. Okay, so in step 3, let's say by induction, we recall that 2 to the k plus 1 is less than 2 to the k. And what we'd like to do is we'd like to somehow make the inequality look like this. All right, so our goal is to build this from what we have. And with an inequality, we can add anything to both the right hand and the left hand side as long as it maintains the inequality. So wouldn't it be true that 2k plus 1 plus 5 is less than 2 to the k plus 6, because we know that 5 is less than 6. And we can use that to our advantage. All right. And so what we're going to do is we're just going to add special numbers or special terms to both sides to make this valid. And this is probably the hardest part of these sorts of inequalities. So what I'm going to do to the left-hand side of this inequality is I'm going to add 2 to the left-hand side, because I know that when I factor that, I'm going to end up with 2 quantity k plus 1 plus 1. All right, and that gives me the left-hand side. All right, and on the right-hand side, what I'm going to do is I'm going to add another 2 to the k. All right, now I'm going to erase this really quickly because I'm not at that stage yet, but that's what we're trying to do, is we're just trying to add something to both sides that's going to build this inequality, okay? Now, what's the justification for this? Well, we know that this is because, so this is valid since 2 is less than 2 to the k, all right? So notice all I did was I added 2 to the left-hand side and 2 to the k to the right-hand side for all k greater than or equal to 3. And I don't think anybody doubts that, right? Now what we're going to do is we're just going to perform some algebra. Okay, we're going to factor out a k plus, or factor out a 2, and we get 2k plus 1 plus 1. And these are like terms now. Okay, so I look at both of these, and these are both like terms. So we get 2 times 2 to the k, and the justification here is factor, and then also like terms. Right? Notice that this is 2 to the first power. And whenever you have like bases, you can just add the exponents together. So this is going to become 2 to the k plus 1 plus 1, which is going to be less than 2 to the k plus 1. Okay, and that's by our exponent rules. All right. Now, if we look back up, that's exactly what we wanted to get right here. We wanted 2 quantity k plus 1 plus 1, 2 raised to the k plus 1 power. And that's the trick that we're doing with these. All right, we just have to add something to the right hand and left hand side that maintains the inequality, but then when we perform some algebra on it, it gets us to the end. All right, so what we can say is that finally, by the basis and inductive steps, the original statement is true, or in this case, the original inequality. And finally, or let's say therefore, for all n greater than or equal to 3, we can say that 2n plus 1 is less than 2 to the n power. All right. In the next video, what we're going to do is we're just going to take this a couple steps further and show you different types of ways to be able to work with these sorts of inequalities.